Hi, this is Maggie. In this video, we're going to talk about some of the structural relationships between objects that facilitate collaboration among objects to accomplish work in an object-oriented system. Work gets accomplished in an object-oriented system by objects sending messages to each other. This can make it difficult to follow the flow of control. Control can appear to jump around the system, and there sometimes isn't a single object that offers an overview of the system's functioning. Control can be decentralized, which is disorienting when you're familiar with designing in the functional decomposition paradigm. We'll focus here on some of the structural relationships that objects can have that allow them to send messages to each other to fulfill their responsibilities. In order for objects to send messages to each other, they need to have references to each other. This can be accomplished by having an object reference as a field of another object, or by having the object receive the reference to the object as a parameter to one of its methods. We can see an example of both an object reference as a field and as a parameter in the drawBurst method of the starburst class. This method receives a parameter which is a reference to a surface object called surface. The class itself has a field called star, which is also a reference to a surface object. Within the drawBurst method, the starburst object sends the getWidth and getHeight messages to its field star. It can send these messages because it has a reference to the surface as a field. It later sends the blit message to the surface passed as a parameter called surface. Again, it can send a message only because it has a reference, and it has a reference because the reference was passed in as a parameter. So those are two different ways that an object can have a reference to another object so it can send it a message. And there are different ways that objects can be associated when one object is a field of another. It's very helpful to enumerate some of those different structural relationships because they clarify responsibilities, such as whether the object is responsible for creating the field object, whether the field object persists beyond the life of the object it's associated with, and whether the field object is shared among many other objects. We know that parameters are passed to specialize the way a function or method fulfills its responsibility. When an object is passed as a parameter, it is passed for the same reason. For example, in the drawBurst method, we pass in the surface that we want the starburst to draw to. This is a way that we can specialize this method, and it's a way we can write the method so the method is more abstract or general. If the surface being drawn to were a field, then we'd always be drawing the starburst to the same surface, its field, and that would be less abstract. We wouldn't be able to draw the starburst to different surfaces. The program that uses this starburst class can have the same starburst draw to many different surface objects simply by passing them as parameters to the drawBurst method. So the difference between objects as fields and objects being passed as parameters is really whether that object is part of the data of the class we're defining, or whether it's a specialization of how a method is performed. If the object is part of the data, if it's integral to the object fulfilling its responsibilities, then it's a field. If it's not, and if it's something that we want to be able to specialize in a method, then it's a parameter to a method. All of the structural relationships we're going to talk about in this video would follow design decisions that were based on a requirements analysis of the system being developed, followed by a design process. We will touch on some software engineering, but primarily our focus is going to be on how to design and program small object-oriented systems. So in many cases, we are going to assume that a requirements analysis led us to make the design decisions we are making. So requirements analysis led us to believe that a particular structural relationship was the appropriate one for the system we're designing. So let's look at some of the structural relationships that define objects as fields of other objects. What situations arise? The first association we'll look at is a bidirectional navigation association. And this diagram is a class diagram, but it's simplified. We show only the name of the class in the box, and it shows the relationship between two classes as a line. In the case of a bidirectional navigation association, it is a single straight line with no arrows. In this relationship, each object has a reference to the other. The example that I'm using here is one of auction software. The two classes are item and bid, and each one has a reference to the other. The item class has a reference to the current high bid called high bid, which is an instance of a bid class. And the bid object has a reference to an item called item, which is the item that the bid is a bid on. So you can imagine that the item class has other fields like name, description. If you've seen an online auction, you know the sort of information that's contained there. Quite often a picture, return policy, shipping, starting bid, etc. And the bid object could contain the amount of the bid and probably some information about the person or account making the bid. That could be another object, but we are focused only on bid and item here. I just wanted to give a little context so the example would make sense. So the line in the diagram is adorned with the names that the objects use to reference each other. A bid object uses the name item to reference its item object, and an item object uses the name high bid to reference its bid object. Those would be the names of the fields. And it also has the cardinality of these objects. This diagram shows that there is one item per bid and 0 or 1 bid objects per item. Now, of course, that cardinality would be different if we were storing a bid history. Then there could be 0 to many bids in the bid history. Now, our next association is one that you've seen, a unidirectional navigation association, in which one object has a reference to another, but there's no reciprocal reference. This is drawn with an arrow from the class with the reference to the class that is referenced. The example we've seen is the starburst surface relationship from the starburst class. A starburst has a reference to a surface object, which is called star, within the starburst class, but the surface has no reference to the starburst. It is completely unaware of the starburst. And we know, from looking at the implementation of the starburst class, that each starburst has a reference to only one surface, its star field. So we show a cardinality of 1 on the surface side. But a surface might be referenced by many starburst objects in our system. We can create, for example, a red star surface, and then we can instantiate as many starburst objects as we like to use that red star surface. So we show an asterisk on the starburst side to indicate that there could be many starburst objects having a reference to that same surface. You can hopefully see that these structures give us more information about how these objects relate to each other than simply that one object has a reference to another as a field. We know cardinality and whether there is a reciprocal reference. The word navigation in the names of these associations implies that this association is for the purpose of sending messages, for the purpose of fulfilling responsibilities, but there's no ownership implied. The star surface field within the starburst class isn't exclusively a part of one starburst object. It might be a part of many other starburst objects. The starburst isn't responsible for creating the star surface, and if it somehow modifies it, for example by drawing over it, then it has modified it for all other starburst objects using it, probably an unwanted side effect. So the associations give us additional information about how our objects relate that help us make implementation decisions. If we wanted to scale the star surface in a starburst method or invert its pixels or add a glow effect, then we would know to make a copy of the surface and work with that, so we wouldn't alter the surface for all of the other starburst objects using it. So that is 3 ways that objects can be associated so they can send messages to each other. One is that an object reference can be passed as a parameter, and the other 2 are unidirectional and bidirectional navigation associations, which can include cardinality information. All of this additional information helps us make implementation decisions when we are programming object-oriented systems.